So in previous videos, we've looked at inequalities where or an equation, a formula, is greater than or equal to, or less than or equal to, than a particular value. So it's not equal to something, but greater than or less than, or greater than or equal to, or less than or equal to. So what is it with, can we do it with a quadratic inequality? Well, yes, but we need to only to be able to do it with the higher tier. So anybody who's doing foundation here, don't worry, you can avoid quadratic inequalities. But with quadratic inequalities, the first thing we're going to do is factorize it just like the usual quadratics. So if I had, say, x squared minus 2x minus 3 is greater than 0, I'm going to factorize. Now, the factorizing part I'm going to go through fairly quickly because it's been chatted about it in factorizing quadratics video and in FOIL as well. So make sure you've had a look through those two videos, otherwise the next little bit might be a bit too quick for you. So we've got x squared minus 2x minus 3. We're going to put those into brackets, where x's will be at the start. So when we multiply the firsts in FOIL, we get an x times an x, which will be an x squared. Next, we need two numbers that multiply to give 3, and the only two numbers that multiply to give 3 will be a 3 and a 1. So they've got to go at the end. So when we multiply the lasts, we get 3 times 1, or 3. Because it's a minus 3, we know one of them has to be a positive and one of them has to be a negative, because a positive times a negative gives us minus 3. So which one? Is it the 3 that's the positive, or is it the 1 that's the positive? Well, because there's a minus 2 in here, we need to get that value when we add the insides and the outsides together. So if we had plus 3 minus 1, that would be 2. And if we have minus 3 plus 1, that's minus 2, which is the number we have in front of here. Again, if you didn't follow that, make sure you have a look through factorizing quadratics and the FOIL videos. Let's look at it as if it was an equals, rather than an inequality. Well, in that case, either x minus 3 would be 0, because 0 times x plus 1 would be 0. Anything multiplied by 0 is 0. Or x plus 1 is 0, because x minus 3 times 0 would give you 0. And I can then from there work out that if I move the minus 3 and the 1 to the other sides of the equal sign, it becomes x is 3 or x is minus 1. So how does that help us with the inequality? Well, how I'm going to show you that is, first of all, we're going to plot it on a graph to have a look, or at least sketch it, to have a look at how the quadratic function behaves. Here we've got a Cartesian graph. We've already had a look at how we plot linear graphs, but we're going to look at a sketched quadratic graph. We know that the 2 points on the graph when y is 0, x will be these two values as we've worked out. And from our inequality, we know that the number at the end is minus 3. And just like with linear equations, the number at the end is where it crosses the y-axis. So our line needs to cross the y-axis. Now, as you can see with this one, unlike with a linear equation where you only have 2 points and you just simply join them up with a straight line, with this we're going to have 3 points. Here at minus 1, 0, here at 0, minus 3, and here at 3, 0. So when you join them up, you've got to join them with a U-shaped line. And that's what a quadratic equation always looks like, either U-shaped or an upside down U. We go into plotting functions in more depth later on. You don't have to remember this for the quadratic inequalities, but what I'm doing to show you is that our equation at the moment is where the line is greater than 0. So if at these 2 points the line is 0, it's anywhere over these 2 points where it's greater than 0. So if we were at, by here, the 3 is spot on where y is 0. If we went to 3.5, y would be 3. It's now greater than 0. If we went down here to minus 1.5, y is now 3. So it's greater than 0. So any of these 2 points to the left or right of our curve is where the value is greater than 0. So we can say that when x is greater than 3 or less than -1, as shown by this double inequality here, that is when x squared minus 2x minus 3 is greater than 0. So when you're trying to remember if the equation is greater than 0, then the 2 values you've worked out, x is either less than the lower or greater than the higher value, and hence you get a double inequality like this. So this equation can be represented as the double inequality here. Alternatively, say we had it the other way around, where we've got x squared minus 2x minus 3 is less than 0 instead. Now it's any of the points within the line here. So for instance, if I went to where x is 0, y is minus 3, y is less than 0, it's minus 3. So any of these points within here are where the equation is less than 0. But I can still create an inequality, because in that case x is going to be greater than the -1 but less than the 3. So if you're creating an equation where the equation is less than 0, then we're going to it's going to be greater than the lowest point and less than the higher point that we found out when factorizing. And that's how we change an inequality equation into a double inequality.